Hello again. Today we're continuing with our gas laws and learning about Gay-Lussac's law. So we've learned about Boyle's and Charles' laws already. So with Gay-Lussac's law, one of the main things to be concerned about is that it is another direct proportion. So when we say that, as we read through our definition, it says the pressure, okay? Back to, or similar to Boyle's law, it involves pressure. But then it says the pressure of a given amount of gas is varying directly with its, again, Kelvin, super important, Kelvin temperature. Notice that volume is constant. So remember that if we have a direct proportion, as one of those variables goes up, other one is going to go up. So as temperature increases, pressure is also going to increase. Volume is constant in this case, so you will not be given a volume. The volume will be constant, so it might say something like in a steel container, so the volume would not be fluctuating, or I think I already said this, but it would not give you a volume. Okay. Again, similar to our last two laws, you're given two pressures. One will be your initial pressure, one will be your final pressure. Two temperatures, you wouldn't be given both. One of them would be what you're looking for, but two temperatures, one would be your initial and one would be your final. All right, so let's go ahead. All right. Gas in a sealed container. Okay, so that's what I was talking about with the volume. Notice it says a sealed container. So that indicates to us that volume is constant. Has a pressure of 125 kPa at room temperature, or it does not say room temperature, I'm reading crazy things. A temperature of 303 Kelvin. If the pressure in the container is increased to 201 kPa, what is the new temperature? All right. So I'm going to go through and underline the things that we are given, and just like we've done with our previous problems, I'm going to write down what I'm given. So I'm first given a pressure. And a temperature. So the first pressure I'm given is 125 kPa. And notice I don't need to convert my pressures. So where temperature has to be Kelvin, I don't need to convert my pressures to, if I'm given kPa, I do not need to convert it to atmospheres or millimeters of mercury or anything like that. Okay. It gives me my temperature in Kelvin. So if it's already in Kelvin, I don't need to convert it to anything else. And then it says if the pressure in the container is increased to 201 kPa, so it's telling me that this pressure is changing over time. So that's going to be my pressure 2. So this is my pressure 1. All right, and it wants to know what the new temperature will be. So that would be my T2. That's going to be my question mark. All right, so this would be T1. All right, so I'm going to set up my formula. If volume is constant and I'm given two pressures and I'm not given two temperatures, but I know I'm solving and I need two temperatures in my formula, then I have to have Gay-Lussac's law. So P1 over T1 is equal to P2 over T2. So this is a similar setup to the second problem on my Charles law video. So I'm going to go ahead and show you how I like to do these problems. You can, if you would like to, go back and watch that video. and see a second way of solving it, but I like to solve these using cross multiplication. Again, there's another way if you want to go back and watch that on my Charles Law video. Okay, so what I do is I cross multiply. We are solving for T2. So remember, if I'm solving for T2, I need T2 on the top, which means that I need for my answer to say T2 equals something. Right now I have T2 on the bottom, which is not working for me. I need T2 to be on the top. So the way that I like to do that is cross multiplication, which means that I'm going to have P1 multiplied by T2 is equal to, then I cross the other side, P2 times T1. Now I have T2 on the top, but I don't have it by itself. So I can divide both sides by P1, and now I have my equation set up with T2 equals something, which is my goal, and specifically I have T2 equals T1 divided by P1. And I can plug in all of the variables that I know. So I know T2 is equal to, make sure that you are plugging in P2. P2 is on the top, make sure you plug in P2. So I have 201 units, KPA, multiplied by my T1, my only temperature, is 303 Kelvin, divided by my P1 is 125 KPA. Before I actually go to plug this into the calculator, just like I've done in all my other problems, or most of my other problems, I'm going to make sure that my answer is going to be in the units that I want it to be, and I'm going to make sure my answer makes sense. If you remember from the beginning, pressure and temperature are directly proportional, so as one goes up, the other one goes up, or as one increases, the other increases. So my pressure is going from 125 to 201. So my pressure is increasing. That means my temperature should also increase. That means my temperature should be something higher than 303 Kelvin. The other thing that I'm looking for, I need to make sure my answer is actually in Kelvin, which means that this KPA needs to cancel. Does it? Well, I have KPA on the bottom. It does. Okay. I also want to make sure, like I said, that my answer is in a temperature unit, which is Kelvin. So this Kelvin should not cancel. There's nothing for it to cancel with on the bottom, so I'm good to go. Now I can plug that into my calculator. I have 201 multiplied by 303 divided by 125. I get 487.224. So I get T2 is equal to 487 to Kelvin. And that is Gay-Lussac's law.